Hi everyone, it's Nono here one more week, and I want to welcome you to my live stream. I hope that you can hear me okay and you can see me okay. We're going to get started right on. And I will remind you, as always, that you can support the channel by simply liking this video, or if you're not subscribed yet, make sure to subscribe if you want to get notified when I go live next or when I upload new videos. We have a Discord server. This is a community where we can chat, and it's at None of the Masas Discord, so feel free to join. Let us know what you like doing and what projects you're working on, or maybe to share things that you're passionate about. And last week, we took a look at the Stream Deck, which is a hardware device I have here with me today, which I just bought, and how to record markers in Python, something that we're going to be using today. I'm gonna try to get used to doing this so we can create markers for YouTube videos, for video tutorials, and for podcast recordings on the go without having to do it after the fact and do it right in. I'll explain a bit more how that works. But yeah, so I will remind you also that, as always, you can submit questions to the Getting Simple podcast for the latest or any previous episodes at gettingsimple.com/ask. And here we have the community goals, which we're talking more and more lately. We're getting to the end of season 2. We're not going to be live streaming in August. So this is the one out of the last 8 live streaming episodes. So we're going to have 4 more, I think, in June, or 8 in total before August comes. And today, it's a bit open-ended. As many days lately, we're trying to see if we can come up with a structure that has a bit more continuity, choose 1 or 2 projects and work on them more thoroughly, and maybe leave some parts of the live streams for more flexible topics, right? I would say I want to comment a bit on what I did last week before we get started looking at other things. One thing that you might notice, I have the same setup that I had before last week, and that's because I took the lights really close to me. I'm like lighting the chroma with some side lights, which makes it work better mainly on screens like this one when I have another background behind me. And yeah, so that's basically it. I'm not prepared in terms of having other slides. There's no set topics for today. I just want to remind you, as always, that you can write on the chat and I'll read the questions and can answer them live as well. All right, so let's close this, and I'm gonna add a marker here. So I have my my Stream Deck here. I don't know if you're gonna be able, if I can reach to show it on screen. So yeah, I guess we can. So this is the Stream Deck, which you can see probably super small, but maybe looking at my hands, you can see the size of this device. I'm gonna put the other camera. So this is currently my Stream Deck. It's a bit weird because some of the icons that have green color on them will show as transparent, even though that's blue color, but I think it's reflecting in some way. And the main thing, so what we did last week, that I was talking a bit about the Stream Deck, and we're gonna upload an introductory video that I did before I had this thing on my hands. I just got it shipped a few days back, and I have a few videos with the unpacking. And the first thing that I want to do, so let me go to my recordings folder. So today I'm not only live streaming, but I'm also recording locally with OBS. And that means that there is this MKV video that got created when I press record right before I pressed on live streaming on YouTube. And that means that our markers are going to be maybe a bit shifted, but there is this txt file that goes with the same name of the MKV, and hopefully we don't have a lot of lag on the recording. But what you can see here is that I clicked on some of the buttons that I've programmed from the Stream Deck, and we can see what those are on the Stream Deck application, right? So this says that for the Stream Deck XL, these are the buttons that I have programmed. The white ones I'm programming thinking mainly on the podcast, and these ones here I'm thinking for the live stream, but these are just kind of play buttons that I'm testing to see how the thing could work. There is a Python script behind that we coded on livestream 76, so we did that live and we're also editing that video. And the thing of this, the gist of it, of that script, is that I have these things here. And let's say that I want to take a break now. And I'm going to remove this one so it doesn't really matter. But here really I'm showcasing the Stream Deck. So I could actually come here, Stream Deck demo, right? And that would be the marker for this section, what we're recording right now. And, I could edit this and remove it manually. And when I click, so for example, the mistake button that adds there, or the break button, break end, and I can, I can press section marker, overtalk, and other buttons, right? The thing that this script does, so if we press, for example, if we remove these ones now and press section marker, is that 6:44 is the current timestamp of the NKV video recording that shares this name. What this allows me to do is to click one button here and know that there was a break there, or that this was a today section, or that there is a section marker which we would have to edit later and say, for example, demoing Stream Deck, right? So this actually is demoing the Stream Deck demo, adding markers maybe, right? Like we had something there that maybe that's what I intended to do. Something like that, right? And if I were to show something different, I could press section marker and I know that that section is going to start now. Next thing is like maybe we could have like an on-screen text input, and I could maybe write there the text of the section marker that I want. But anyhow, I think this is working great and I'm going to be using it today. So you see my, and maybe here we could do that. Oh, I did something weird. So if I show you my Stream Deck configuration that I have here, I've just put a few buttons on the top left for controlling keynote, markers on the right and the bottom. This just is a button that like makes the Stream Deck go to sleep. These ones are for the toggle program, so I can do time tracking. So I could click live recording, and that actually is now the state that shows on my device. So I could stop that action, or I can continue that action. And yeah, I think like if we click on section marker again, that doesn't really do anything here, but it does add on to this document, right? So we're gonna leave that as it is at the moment. And we're gonna take a look at the marker script. So this is a script that we did last week. So a little recap there. We actually can see the parameters from the bottom of the script. So we're taking text, directory, and file. So you can either specify a directory and we'll look for media files that are, for the latest modified one that is supposed to be the ongoing recording, or a specific file. And from the latest file that we see on a folder or to an individual audio or video file, we'll track the creation time and the current time and then see at what timestamp we are. Basically just looking at the diff and then creating that marker. And there's some logic here. These are the formats that I added support for, but we could just add the strings for any extensions that we want to support. And here we have the lapse seconds in start, the duration seconds, and the second to timestamp, and then the timestamp. And these are just helper functions that allow us to do that diff between the creation time of the file and the current modification time. And just a few things. This basically tells us the duration of the file, and then we convert that duration to seconds and minutes and seconds. Then we just convert that to timestamp format, and then we have a helper function here just to call that with a given path. So that is just a recap of what we did last week. And now we're going to take a look at what we tried to do, which is definitely not finished, but we will continue working on it. So we have the live stream notes here, and I've been talking to some collaborators that are going to be starting testing with me to edit things like adding markers to streams that don't have editing videos, and doing some other things for the podcast. So if you're interested, just reach out on Discord, and I will get with you and meet and see what we can do. So Live 77, we plan the end of the season, so that's what I want to what we said. We have to plan the end of the season. So these are the live streams that we're going to do before the end of season 2. This is Live 77, so that's so this is actually today, June 9th, and next week we have Live 78. I want to create a survey just to know what you want to see on the live stream, what topics are more interesting. I was talking to Sachin Davas last week or early this week, and we discussed that probably what we want to do is more entry materials for people who are newcomers into creative coding and machine intelligence, and not get super, super deep until we've developed previous topics that people can learn from, create playlists that can be played consistently. And I also talked with Rob that we should create topics that are, have more continuity, right? Dates for a community call. This keeps getting postponed, and I'm not sure when that's going to happen. Show interest if you just let me know on Discord or on the YouTube comments. And the end of the season. Okay, so use the sketches dataset for different purposes: object detection in scanned pages, similarity sorting and search, GANs to generate new permutations. I have been taking a look at a video that we recorded, I think, earlier this season, I believe, so this last year. And it is a video that explains how to download all my sketches by looking at the RSS feed URLs of the images in different sizes, and how to parse those, or basically add them to a download queue in TypeScript, so you can download all of the images. And we could use that to download images from other RSS feeds as well. But in the purpose of my project, the sketch.none.map blog, what we want to do is download all of the images and use those images as a data set, and also edit more of the images that we have locally, in order to have a greater data set that we can use for object detection, similarity sorting and search, generating new images, and image classification. All right, so here I'm going to take a quick break, and I'll come back, and we can go here to the break slide, so when I'm back is when this slide is not there anymore. Okay. And as I said, I'm trying this thing with the chapters so we can have the chapters hopefully in the future, even right at the end. Maybe today we can try it right at the end of the stream. Okay, so we are back here, and I think so that that's clear, right? So that is sort of a recap. And let me add a section marker here because you see, so let me add it, but this actually is a bit distracting. So we can say here, and yeah, so we're gonna review quickly some of the topics that we have here, some of the things that we've done, and what things we want to clean up. Sort of like a recap and a to-do list for what we want to do in the future. There's like a ton of topics here, so I'm gonna open two of these lists, and we're gonna do this. So I'm gonna do this quickly live, and you can maybe jump ahead in the timestamp if you're watching this offline, if you don't want to hear this part. But that's what we're gonna do right now. All right. So in topics, we have a huge list of things. This is like way too many things, and they're not sorted properly by topic. I think in the future, maybe YouTube could develop a function that says skip silence, because that's what I do at the end of the day with this script many times when I edit videos. All right, YouTube API, upload videos to YouTube, update thumbnail. So we've done this one. So upload videos to YouTube with the Python data API. We haven't done the others. This is automation and workflows. And auto zipping files. Yeah, this I have. So coding best basics. What's a REPL? Yes, build. We do have a video on this, right? But we have to edit video. Machine learning training style gun with my sketches. I feel we've done this. I'm not sure if we trained it during the live stream, but we'll see. So code challenges. Write a simple TensorFlow model, convert it to TF-Lite, run it on the iPhone. So yeah, this could be a section called challenges or exercises. Challenges. Maybe we just put this here. Peaks to peaks on runway. Train, load, debug. This we do have already, that we already did. So track down existing live streams, maybe edit. Right, so quantified self, build a weight markdown app. So these are things that don't have to do with machine learning. So maybe this is something separate. Other request, can you do a video on how to display data on the browser that we got from a WebSocket stream? This I'm gonna remove because we sort of have done that. Okay, so web development, web DigitalOcean. We do have that. We need to edit recordings. REPLs. Coding basics. And if you connect online, feel free to let us know what other things you would like to add to the topics list. But this is a bit challenging because there are just way too many things that we have here. Coding basics, web, standalone, custom video player. This is more, for me. I already tested Livewire. So maybe we remove this. Text expander and automation. This is more like automation on workflows. Yeah, so how to create a Python command line interface with ArcParse. I think we do have that, but it would be good just a video showing how to do that with like maybe like different data types and maybe also user prompts or something like that. Scientific notation. So this is Python. This is coding basics. Git. This we're gonna remove. This is like a getting simple template. Google Chrome's copy to highlight feature. Yeah, rename scripts. Thumbnail generation, Typinator. We already have Typinator somewhere else, but this is, yeah, workflows category. macOS, location of voice notes, embroidery. Michael, remarkable. Aziz. All right, many things. As you can see, we have too many things here. TensorFlow full updates. Um, maybe, MVM. Yeah, I think we gotta remove some things because we're not gonna be able to do everything. Yeah, many of these things probably we can simply remove. Swifty Tesseract. Nope. Delete. Blotter. I think we did cover this on some video. So blotter. Labeling sketches in scanned pages. I think this is already done. So that's CVAT. This is data labeling. Building a GAN from scratch. Building an Electron app to query a database associated of data associated to labeled images. Yeah, that one is interesting. I wanted to build that one. Building a GAN from scratch. So that's machine learning. So we can get this up to machine learning. Activation map. So that's kind of machine learning basics. Cables.gl. So this, instead of doing it a live stream, I'm gonna save it here just in the future. If we want to do a video, I'll put it, but I need to kind of remove or like reduce the size of our list. And for those of you who missed that, this is a list I have at nonodoma/stars. Right, so it's just a list with things that I've liked on the web. Okay, let's make this a bit bigger so you can see better. Detectron 2. Okay, so this is more for object detection. So maybe let's move that to the machine learning section. Okay, in this, maybe this is something that we can continue doing now, but I think I need to just take a look at everything and compress the list a bit and get to choose, right? Like get to choose what things we could do or what things don't make sense to do on this live stream and just make a list prioritizing. AWS. I don't think we're going to do anything with AWS in the short term or audio editing libraries, right? So This maybe I can set here some sort of archive that we're not gonna do at the moment. Quantified self. Code challenges. Machine learning, web development basics. Put this here. Labeling and object detection dataset. Okay, that's data labeling. And we do have two different machine learning sections. So maybe we can get all of these ones together up there. Yeah, and I can see there are many similar sections. Luckiest guy. What is this? So this is a font that I liked, similar to some of the fonts that I was using on the live stream before. Probably not something we're gonna use. Develop Audition, Adobe Audition to extract markers from session files. Get, okay, so this is coding basics. So that's Git. Maybe there is, yeah, I don't know if it's workflow and automation. DoodleNet, papers. We're gonna remove this one again. We have crypto here. Okay. So these are more workflows. So we can probably move these ones above. So this is what happens when I haven't been doing a great job in organizing this over time, right? Like just been adding things to this list, but not really sorting too much. Okay. Yeah, and this is hybrid task cascade for instance segmentation. Draw pile, suggestive drawing, AI drawing. We do have another merge with list below. TensorFlow JS, Lobe. So this is more machine learning. Draw pile. So this is a free software that lets users draw on the same place or reference app. This is to go with this. All right. No, ESP, Adobe Audition. So this is a script that I just barely started some time ago. So this is actually dating back to February 2020. That's old. And we were just reading the different audio clips from the from an Adobe Audition session. So this is to be able to read the markers directly from a session and not having to read those from basically an export, opening the program and exporting. Maybe we could read them directly from a WAV file. That would be even easier because I already have that code in PHP. Okay, so this ML course with Juana. So this is, I'm gonna merge this because I have a few different documents with people. So maybe we can merge those together. ML course. So we have more here. Collaborative AI sketching. Yeah, we have a lot of stuff here that I've kept on the same place. And these are job descriptions, tutorials to record. Yeah, we have more topics here. Yeah, so this one we have above. Okay, so I'm going to transition again into a break, so we'll be back again soon. All right, so we're back from the break. Let's take a quick look at our precious markers. So we do have some thing here to take a look at after we finish today. I'm gonna also take a look at the stats on OBS because we are recording locally as well as streaming, which seems to be going pretty well. And okay, so I'm gonna leave aside a bit those topics. So this list of topics I'm gonna leave. I need to clean up, but it's a second approach. We took a look last week. And what we can do, I want to get back. So let's make a section marker. I want to get back today at machine learning because we've been doing many other things, but arguably the projects that we're doing here is to basically learn machine learning and teach machine learning to those who don't know. So to also learn for me, right? Like that's also my goal. And if we go to collab.research.google.com, not con, but com, we have many notebooks that we've done before. But today I'm just gonna, and I don't know why this is showing in Spanish now. Maybe let's just do US or N. Yeah, so English. And I'm just, so let me double check really quickly here what account I have set up. All right, so this is the right account. We could use the live stream account, which I don't have at the moment, but let's actually use it because that's the account that we're supposed to be using. So this is going to be live.nono.ma@gmail.com, which we could do at some point. We could have something there in the actual URL. And I think that's my password for this account. And that's it. So we're back to Colab now with that account. Doesn't show us we have any notebooks here, but I remember we did. So let's just create a new notebook here. Okay, so we have an empty notebook. And the first thing we're gonna do, we're gonna import TensorFlow. And we can print here the TensorFlow version. First thing that this does, it's connecting to the notebook. And we'll see the default version that Google Colab is shipping as of June 9th, 2022, which is TensorFlow 2.8.2. This tutorial, which will be part, so I'm starting just to think of like generating content for our course in the future, is going to be creating a TensorFlow model. Like this is a custom TensorFlow model, right? And in here, I think I can switch this to text. How do we, okay, so text cell there, creating a TensorFlow model. And at the end of the day, we'll have a model that we can use to call model predict with our inputs. And then those will be our outputs, right? So this is, at the end of the day, what we want to do. We want to have a model for which we can predict with a set of inputs and get a set of outputs. And that input can be an image. So you input an image, get an output modified image or like a class, or maybe get text and then get some rating or some generated image, right? But our models, if we create them customly, unless we do get some complex model or build some material from paper, we'll have a model that is fairly simple, right? Because we can only do so much by writing a network from scratch unless we build on top of the shoulders of others. Okay, so let's take a look just for me as a refresher, I do have some notebooks, actually, probably on my other account, which have to do with autoencoders. That's livestream 33 and livestream 34. And one thing that I just thought, and this is a bit of a digression, so I'll put here digression. Right, so what you see there is that I've said that at this minute of the video I've digressed and I'm gonna do something completely different, so I can choose whether to remove that or to add a chapter marker text. And what we are about to take a look is, like, I could do here Stream Deck, and I can just copy this. And what I've been doing, I do have a template. So where's my PSD icons? So I've just been building the icons with Photoshop. So creating a custom Stream Deck marker button. That, bottom. And supposedly we've opened that, but it didn't really open anything. So this is Photoshop. And I'm just gonna create another icon. So we'll clone this one, for instance. We'll just put here link, and this is gonna be a marker that I add when I want to add a note that there is some link or some person, some book, some link that I've mentioned, something that I've mentioned that I want to link later from the episode notes or from the live stream notes or from the podcast episode notes. So we're just gonna export to a folder here, and we should have our icons in here. The thumbnail generator in macOS is not working properly lately. I don't really know what's going on, but I hope they fix that soon. And I'm pretty sure a lot of people are complaining. So Stream Deck, we open that, and then we just get the link image, put it on a new. So I'm gonna copy this here. I'm gonna drag and drop to this icon, and I do have a command here that says link reference. And as soon as I do that, this shows up on my hardware device, and I can click link reference, right? And every time I click, it will add it with the current timestamp of the recording. All right, so we can delete that. And now I guess I'm gonna finalize this here, and this, and this, and we can continue. All right, so I was talking about the stacked autoencoders, and this has two parts. So maybe let's go to the second part, because maybe that is where we have the completed model, the model that was more final. And so we're gonna open that notebook. I think we do have, okay, we have this other notebook here. And here we were importing NumPy and matplotlib, and we were creating a sequential model. We were creating two different models here, and we were compiling the model, and then we could get a summary. So let's just write the steps here. So the steps should be define a sequential model, compile it, print a summary, train, and predict, right? So those are the steps, unless I'm missing something. Yeah, train or fit. And train is with like .fit, compile is .compile, this is .summary, and this would be .predict, I think. Model .compile, summary, fit, and predict. All right, so here we can see that we've imported with TensorFlow, and we're just doing TensorFlow.keras.models.sequential, and that would be define a model. So our model is going to be, let me see, how can I maybe put this to in full screen? All right, so we can do swap now desktops. Okay, so we get here, this model is going to be TensorFlow, and directly goes to the Keras API models.sequential, and we're going to pass an array of layers. We're going to do here model compile, which will have to pass in different parameters. We're going to do model summary, and we can split these ones into different cells actually. Then we'll do model fit with some data, and then we'll do like what we said before, right? We already have that below. Okay, so I'm going to put this here. I'm going to split these on different code blocks, right? So we'll just leave this, and this, so we can run them separately and nothing fails. Train. All right, so if we do this, right, so if we just print our model at the end, we do have a sequential model, but it's empty, so we don't have any layers there, and it's not gonna really like it because we cannot do anything. So the first thing we can do here, I mean, this is just like two dense layers to get like 30 units of an image input. So this is an encoder and a decoder architecture. If we don't have the decoder network, when let me actually use this now that we have the time. I have some time here. Let me see how much time I have left. Okay, we have around 20-25 minutes. Okay, so I'm going to plug my Remarkable tablet. Let's see if that's easily synchronizable now. So I have that here. And we're going to accept the connection. Right, and that should be it. So this is not going to be live 73. We didn't end up using tablet in live 73, it seems. It's going to be 77. All right, so let's recap a bit here what we want to do. All right, so let's take a look at what we want to do. We want to first define a model, right? It's going to be with TensorFlow, but we could also do it with PyTorch. And maybe that's something that we want to get into, right? Like how to do things both in TensorFlow and PyTorch. We have a model and we need to do model dot compile. So because we define the model with an array of layers, so we have like the input layer, and then we have other sort of operations that do something to our input. So if we have here maybe an image, maybe we have an input function that makes that a like a flattened layer, and then we do some other dense operation that manipulate our images into like even smaller sizes, right? And those are the diagrams that many times we see as something like this, right? Like this is just like a 28 by 28 image, and that goes into a one-dimensional vector that is just like a flattened operation, and then maybe that gets into like less and less digits. Like we maybe go from 28 by 28 to 768 digits, but then we maybe go to 100 and then just to 30, right? So we are encoding a 28 by 28 image into 30 digits. And that's a really common operation. This is, we're actually encoding and we're losing information, but we're like embedding knowledge of the data set. If we just do that, if we just encode, we're not going to actually gain a lot on the training process because the model doesn't really know what we want these digits for. But if we get those digits back into a 28 by 28 image, if we try to decode them, then when we train the network, it actually is doing that process of like going from something that is actually pixels into like a tiny vector tensor of images, and then we're like augmenting that back to another image. So we want to encode here and decode here because we actually want to be able to do this part here, right? Like let me go back. What we're really interested in is later maybe being able to go to from 30 digits to like 28 by 28, and that is a decoding process. So we would have here like digits and have here an image, and we can come up with new digits, right? Like we can add new digits here, and we'll be basically generating new images. All right, so that is specifically, that's nothing to do with just machine learning in general. This is actually a specific type of model that we covered on livestream 33 and livestream 34. So we're today in live 77. A lot of time has passed, but as I say, as a reference, live 33 and 34 is stacked auto encoding. coders. And that is something good to learn because I think it's a great way to understand a bit of machine learning, because the training loop does something which is basically go from big to small and small to big. But really, the part that we're interested here is on creating a decoder, which at the end of the day is a generator, right? All right. So uh, on line 77, we were talking about the concept of defining the layers inside of a model and then compile it with a specific. We're going to take a look. Where is this now? All right. We have here a set of layers and another set of layers here. And when we compile, see how here we create the autoencoder, which is basically two models, the stacked encoder and the decoder. And we have a custom metric we are compiling. So we're adding here. So this is the loss, the optimizer, and the metrics, right? And then we can print a summary. This is just for debugging, right? So let me move aside. And then we do train, and after some training, we can actually go and predict. In this case, on that model that I was showing, the case is slightly different because, as I said, we're using a different model to train and predict. The training happens with two different networks stacked one after the other, and generating or predicting happens with just the second part of the model. And actually, if we were to just get the first part of the model as a separate network, would be a feature extractor, because we're getting to this part on the left where we have an image and we want to extract those 30 digits. That would be what we understand as features. And the other way around is generating, right? Is decoding, which is decoding the embeddings or the codings from oh, and I was drawing here so you couldn't see anything, but maybe I can just go through once again here. Maybe, well, maybe I just talk through this, right? So encoding or feature extracting, when the model is trained, is going from the actual image to the codings or embeddings, and the opposite process, going from the codings to the actual image, is decoding or generating, if we are actually generating some new data. All right, so here's the process. Model, we define the layers. Compile, we are defining the loss that we're using, the optimizer, and the metrics. Summary, we just see the entire model that we created. Then we train, we need to feed in data, right? So we need to feed different samples that our model is going to learn from. And then we predict. And the prediction is basically getting something into the model and then getting something out. And that in and that out, the A and B, that can be anything. That can be from text to image, from image to image, from image to a classification label, from an image to like a set of bounding boxes, from text to a rating. It depends on how we architect our model and what we do. All right, so let's continue here. I see my time is running. I have 15 minutes left. And maybe I should put a timer, but the most important thing is we need to declare topics. All right, so sequential. So just taking a look at what we have on the other example. TensorFlow, keras, layers, flatten, and the input shape is 28 by 28 in this case. So we're assuming we're inputting an image here, or just like a tensor that is 28 by 28. So I'm just simply copying from there. We can take a look at other network architectures in the future and modify this. And or maybe let's do that now. We can just take a look quickly. All right, so model, so TensorFlow, model, sequential keras. Let's take a look at an example. All right, so this is actually making a sequential model differently without passing the and I don't know if we need the dot model anymore. Maybe we don't. So we have the input shape, and this could be, we don't really need a flattened layer as the first shape, I think, if we just do this. But well, we have the input flatten layer, so we can go with a dense directly. But we do automatic shape inferencing. All right, this is identical to the following: sequential input shape. Right, so okay, so we could actually have done this here. So we could have done TF keras layers. Well, how are they doing? So just TF keras input. Okay, input, and then we can do here shape equals 28 by 28. Why are they putting the comma? Is that because that makes it be able to take any type of any amount of input, like a batch? Maybe. All right, so let's just leave this. Well, let's just remove that part. All right, so let's see if this works. Okay, so that seems to work. Let's make here keras flatten. I don't know if we can probably just do layers flatten, and we print the model again. So if we try to print the summary, probably, okay, so it does let us do it. So we get the input, and then the shape is 784. We have the input shape defined here, and we're going to compile here. So if we take a look at compile, as I said, we need to say what the loss is going to be, what the optimizer is going to be, and what the metrics are going to be. I think that one is already built there. So stochastic gradient descent, TF keras, optimizers, SGD, learning rate 1.5. We're just copying what we have there. Binary cross entropy. So this depends on the type of data that we're using. Binary cross entropy. And I wonder if we could do TensorFlow keras losses, binary cross entropy. We could also just use the enum or whatever this is called. All right, so we compile, we print, and we still have the same thing. We could actually make a random set of just like a numpy array of 28 by 28. Import numpy as MP, and I believe we could do that. Can we do this? No. Okay, so let me just look. Numpy random array. Okay, rand. Okay. All right, so that should be the size of what we want to do. So let me Or let's do TensorFlow random vector. Okay, that's the one I was looking for. So TF random uniform, and then we do pass the shape, right? The shape 28 by 28. Maybe we can do this a batch already. Yeah, so we're batching this already. We would have to do that if we don't do that like that way. All right, so but I'm gonna move this below. So this cell is gonna be right below, right before. So this is like create some synthetic inputs, and then here we predict. All right, and then we print our input or outputs. All right, so these are so these outputs here is a so we've gone from 128 by 28. So this is basically just 128 by 28 image into a 768 component linear vector tensor, which is just as if we had something like this, right? Oh, like this. If we do something like, well, and we can actually see that by looking at the output shape, right? So 784, sorry. So that's like 20 by 28. Yeah, sorry, 728. I think what I did, what is it? It's like, oh, okay. So that's just 256. Okay. So 786, and that's 184, sorry. And if we put here a 4, we actually get 4, right? And we could visualize those with matplotlib. We haven't trained the model, right? That's something, it's important because what's being generated right now doesn't make any sense, and we'll see that in the future. All right, so here's how to show a set of images. So it shows them all together. And what we're doing is we're getting a set of images. So we're creating a plot, and we're just making subplots, but we don't have to do that, right? So just let's just take a refresher here, how to matplotlib show TensorFlow tensor. Seriously, you're showing me this? I'm not sure if this is because I am the creator or because this is actually a useful video. All right, so all right, so import matplotlib pyplot as plt. All right, and we're gonna go below here. So let me actually take a look at something. All right, and okay, so we just do here plt image show, we do have our image. So let's see if our outputs 0 is considered an image. Well, I mean, it's not going to be an image because it's a 784 component thing. So what I'm going to do, I'm just going to get maybe the inputs 0, CMAP is going to be Inferno, for example. We're going to do axis off, and we're going to show the image. Let's see if that works. I don't know if that's going to work. Okay, so that works. So these are the random plots or the random things that are being generated by our the uniform image. So this is 28 by 28. You can count it. And if we put the output here, so outputs 1, right? We're doing number 1 there. So that's not valid because we don't really have 3 components on the like RGB values, right? So we don't really have that. For that, we would have to do some other shape shifting, and I'm not sure if I'm doing that in here. Well, note that if I just put here gray, right? This is the lightness of the color, because if we get, let me try to print here the inputs 1, and we're just gonna get, I don't know, let's see if we can get 30 numbers. So maybe for the first row, so we get the first row and we get 10 numbers. Is that gonna work? So we've got, I don't even know what we got here. Does it change anything? Okay, so I'm getting just 1, and from that one I want to get 5. Okay, so we can get maybe 3 and get the 5 first from each. All right, so this is the brightness. So this is dark, this is light, this is middle, this is light, light. And for this next row, okay, so if we get maybe 5 rows, right, there is like black, gray, light gray, and then white. And you can see this is white, right? This is going up. So these are the pixels represented by these. And the thing is that we have a two-way matrix, which is 28 by 28. And I'm unsure if I can simply do something like this. Right, so that worked actually. And just to get the first row, so this is just 28 values. So I could say, okay, give me just 28 values. And that's it. All right, and it's giving me with Inferno. So I can do Inferno. And what you can see is that we've extracted here the first row. So if you look at the first row here, right? And maybe what we can do is we can get from the input, we can get just like the force fair rows or something, right? Or I mean, actually, we just get the first row. All right, so those match. And what we've done is that, let's go, okay, I'm on time. So let's go back to our remarkable tablet here and go to a new page. So this again is livestream 77. And what we've done there with just with like Python, with the syntax that you can do these weird things, right? So I'm gonna quickly explain how we've done this, right? How we've got like the first row of a 28 by 28 pixel image, right? Like if I just say, okay, give me everything, I'm gonna get a 28 by 28 image, and how we've obtained just a few rows and how the output that is actually 784 84 components. We can get as many as we want. It's just a linear vector. How we just got to display the 28 first elements here and just the first row of the image, so it actually shows the exact same image. So if I go back to my drawing board, if we have a model, so what we've done is a model in TensorFlow, and our model does something really simple. We get an image that is 28 by 28. That's the input of our model layers. We have first a layer that is an input that has that shape of 28 by 28. And this thing here, I believe that comma gives us, so it has a non-batch, so we can input many 28 by 28 images in a batch. And then the second layer is a flatten. And what that flatten does is that it makes our 28 by 28 image go from something like this that has rows and columns into a simple one-dimensional vector. So 28 by 28 is 784, right? And that's it. So this means that our model gets this image and gives us a really long vector or tensor that contains all of those same pixels here. So if you look at the corner of our image, and our image had like pixel A, pixel B, pixel C, right, up to 28, then we'll have here A2, B2, etc., etc. So in here, we'll first go with A, then B, C, and then add that. And when we finish the first row, we'll start with A2, and that will go here, B2 will go here, C2 will go here, right? So you can imagine that a bit. So if we continue here, we have our image. And what I've done with the Python arrays is that we do have a tensor in TensorFlow. And if I tell it, right, let's say that we have our inputs and we have an array of inputs. So we have many 28 by 28 images, right? One after the other. We could first say, okay, give me the first one. So inputs 1. And now that we have that one, so let's say that we say that our image equals inputs 1, right? What we're going to do next is that we can say, give me from the image, and then do just the first row and everything from that row, right? What will that show? That will show just this row here, right? Because we've told it, give me the first row, and from that row, give me everything. But we could have also said, give me the first row, but only give me 10 pixels. And we just get the 10 first pixels. Let's try that in code. So we go back to our notebook. We have our inputs. So we say, okay, so give me input image 1, right? So we can say that we're going to plot that. Let's quickly make a function for that. So let's make really a helper function, show image, and we're going to put here the image. So we're going to put here all of this. And we put the image, right? We run that, and then we can say here, okay, show image. And that's what we show, right? But we could also say, okay, show image, and now just show me the first row completely. All right, we could say now, okay, just give me the first 5 items on that row. Or now let's swap that to say, okay, now give me the items on the last row. Look that they are like purple, black, dark purple, purple, yellow, right? 5 items on the latest row. So that's going to be row 28, right? So we go, if we do this, is 28 items, but if we go from 27 to 28, it's just the last one, which matches with what I've said before, right? We could slide in, so say, okay, give me from the number 1 to 5, and we skip that one, right? Note that the color range now changes because we don't. So let's leave this at 0, right? So we get. Let me just do this. All right. So what's happening here? Okay, so this is not the last row. So we're just gonna do this. All right. And hello, Daiminas Kudkevicius. Where are you connecting from? So we're wrapping up today, but I hope that you can go back and watch. I would love to know, what are you looking for? How did you find this channel, and what are you looking for? Hi, Daiminas, in case that you're not hearing us. All right. And so what I'm trying to do here, now that we have this, I was saying that I can skip that first one. All right. So this is working, and I could get one on the right? So we're sliding, and we could actually make a really nice GIF if we just like go and slide, because it's going to get that sense that we're sliding here, right? So if I say, okay, this is my first one, and I, how can I do this? All right, so if I just save them manually, this is going to be a bit slow. So we just do 0, 1, and then we do, okay, now it's going to be 6. So we run this, and then we save, maybe just a slide 5 times. 0, 2, 2 and 7, 0, 3, 3 and 8. And one thing that might happen, and I'm not too sure, if the ranges change, the maximum and minimum numbers change, we might get that some colors are actually also changing. But we'll see. I'm just gonna build a really quick GIF, and because this is just like colors, and maybe that's nice as a thing to finalize today's live stream. And we're back at using Google Colab and using TensorFlow and doing things with machine learning. And I hope that we can do more. All right, so back to my terminal. Going to the desktop, I'm going to make some wizardry here with convert delay 1.3 or 2 if we can, well, 3, and then we're going to say everything on the desktop that is a PNG, and we're going to make a live 77 color pixels.gif. All right, so that's super quick. And here we have our sliding GIF. All right, and as I said, the color range changes, so it's a bit weird. It doesn't really make too much sense with what I thought we would see, but anyhow, that's what we made, and we can make this a bit faster. All right, it sort of looks like it's sliding, but yeah, it's not quite what I thought that could happen. All right, so this is just some artifacts of live 77. So we're gonna leave that here as we normally do. I just searched who was coding on YouTube Live, and I've seen you. All right, that's awesome. How do you look for who's coding on YouTube Live? Like I don't know. I wouldn't know how to do that. Like, yeah, but that's awesome. Uh, feel free to like, not to like the video. Well, I mean, liking is loving. That would be awesome. But we have a community at None of the Masas Discord. There's a Discord invite you can join, and there's other people there who code and who are passionate about machine learning and creative coding and things like this. So you're more than welcome to join the community. All right, so let's wrap this up. So we've looked at some of the things here. I have this notes. We were talking about machine learning models, autoencoders, arrays, and here about like accessing these different image sizes, right? Or like array pixels. And the one thing, let me change here to my marker. So live stream 77. On the outputs, we actually had just an array with digits, and I had to actually make it an array within an array because basically you need to have something like 1 by 784 to be able to be shown as an image by matplotlib. In the other case, we do have 28 by 28, which is good. But if we just have this, if we just have 784, it doesn't like it and it cannot render that. So that's the only thing that is different that I had to do for showing the outputs, right? I just have to put here, you see there's brackets around the outputs. So this is what we had before that was failing. We just put the brackets around it and it works. And this Inferno thing, there are many maps, color maps. I know Gray and Inferno from by heart, but I know that there are many others that I cannot remember right now. And yeah, so this is TensorFlow model basics and visualizing tensors as images. And this is from Live 77. So this I'm gonna share on the YouTube video for anyone with the link. We're gonna copy the link and done, and I'm gonna paste this on the live video and on the Discord server. So we're gonna paste that on the live channel. So I'm gonna write here live 77, and the link here is Colab notebook with, and we can paste that title that we had there. That is TensorFlow model basics and visualization, visualizing tensors as images. All right, so that is all for today. Thanks. I think I saw you joining as well, or Dot. I don't know. Two people joined the stream, the Discord server, and I'm gonna finalize now. I think this is a cool image to share. So maybe I'll just do one more GIF before we go. So this is number 1, number 0, number 2, number 3. We have 4. And number 4. Oh, we don't have more. Is this good for looping? Yeah, I guess so. We could create more, but that's okay. Okay, a quick GIF with that would be convert delay 1.6, and we just put this and then put like live 77, 28 by 28 inferno random images dot gif, and we have that. Maybe make it faster. All right, that's the second image, and I'm just gonna copy that name, make a folder, put it within 77 here, and that's it. So great, and I'm going to share that on Twitter really fast. There are some other links that we've used here, so maybe I should post them to Discord on the live channel. So let's just put them there. So let me just move away the tablet. Okay. All right, and before I go, I would like to take a look at how. So not NumPy random. I did look at TensorFlow random uniform. So the random uniform and TF Keras sequential. All right, so now I'm gonna close Discord. I'm gonna close these things. I'm gonna simply point to this live stream. So, and I'll share this afterwards. I'll share this when I have the actual marker. All right, so your dot, awesome. So, thanks everyone for watching. I just want to say thank you for being there. I know that some of you couldn't connect live today, but if you're watching offline, remember, or if you're watching now, remember that you can hit the thumbs up to support the work that I'm doing here, and let me know if you're liking the contents. Maybe also write a comment and let me know, and subscribe if you're new and want to get notified when I go live next or when I upload new videos. There is like a ton of live streams. This is live stream 77. I've tried to do one every week for the past 2 years, so there's a ton of content with machine learning, creative coding, web development, and many, many other things we have to do with automation, being curious with computers and stuff. The community, which I mentioned a while ago, so like a bit ago. And yeah, thanks so much, everyone, for watching. And I guess I'll see you next week. I'll see you next time. Bye-bye. Bye. A really quick note, what did I do here? We're gonna add markers to the videos, right? So I'll add markers to the video. We have, if I have it here, we've taken a look at machine learning models, and something that I had from some time back. And we've tried to just build the basics of what a TensorFlow model is, like a machine learning model, the basics that you need to do to create one with code, and then you would have to develop more. And also how to visualize the tensors, like when you convert an image or some other type of data into numbers and an array inside of TensorFlow, how you visualize that as images to make sure that you understand the data that you're working with. And I do have to go. Thanks for your questions. Feel free to answer more questions on Discord. We'll be happy to help you out, or at least like guide you to see what you can learn next. And yeah, again, thanks a lot for watching, and I'll see you next time. Bye.